Hey everyone, in today's video what we're going to do is solve the limit as n goes to infinity of 2 raised to the nth power multiplied by n factorial divided by n raised to n. Now, usually what we would do is use Stirling's formula, but we're not going to do that today. Today we're going to take a different approach. What we're going to do is recall the ratio test. The ratio test says that if the limit as n goes to infinity of the following ratio is less than 1, this implies that the limit as n goes to infinity of the sequence a sub n is equal to 0. Now what we're going to do is rewrite everything in terms of the limit on the left hand side of the implies sign. We have the limit as n goes to infinity of 2 raised to n plus 1 multiplied by n plus 1 factorial divided by n plus 1 raised to n plus 1 divided by 2 raised to n multiplied by n factorial divided by n raised to n, all inside the absolute value sign. Now, what we're going to want to do is simplify this complex fraction. Doing so, we get the limit as n goes to infinity of the absolute value of 2 raised to n plus 1 multiplied by n plus 1 factorial multiplied by n raised to n divided by 2 raised to n multiplied by n factorial multiplied by n plus 1 raised to n plus 1. We can rewrite 2 raised to n plus 1 as 2 raised to n multiplied by 2 raised to the first power. So we would cancel the 2 raised to n in the numerator with the 2 raised to n in the denominator. And we can rewrite n plus 1 factorial as n plus 1 multiplied by n factorial, because n factorial is just n multiplied by n minus 1 multiplied by n minus 2 all the way down to 2 times 1. If we do that, we get the limit as n goes to infinity of the absolute value of 2 multiplied by n plus 1 times n factorial times n raised to n divided by n factorial multiplied by n plus 1 raised to n multiplied by n plus 1. So what we're going to go ahead and do now is cancel the n plus 1 times the n factorial with the n factorial and the n plus 1 that we have in the denominator. Doing so, we get the limit as n goes to infinity of the absolute value of 2 multiplied by n raised to n divided by n plus 1 raised to n. We can actually go a step further and group the n raised to n with the n plus 1 raised to n. Doing so, we get the limit as n goes to infinity of the absolute value of 2 multiplied by n divided by n plus 1 all raised to n. Now we can actually rewrite this as the limit as n goes to infinity of the absolute value of 2 divided by n plus 1 divided by n all raised to n. Upon simplifying the denominator a little bit further, we can actually rewrite the denominator as 1 plus 1 divided by n all raised to n. And this is really convenient because when we evaluate this limit, we get the absolute value of 2 divided by e. Now, e raised to the first power is approximately 2.7, which is less than 2, so this ratio is always less than 1. Hence, by the ratio test, we get that the limit as n goes to infinity of 2 raised to n multiplied by n factorial divided by n raised to n is equal to 0. Thank you very much for watching. I hope you found that content useful. If you did, could you please make sure to like and subscribe? If you have any questions, make sure you leave them in the comment section below. If you've noticed any errors or mistakes in the videos, also leave that in the comment section below too, please. Anyway, that's all for now. I hope you have a great day.